All right, so here's our beam design example. We're going to go through the first set of steps to design your beam. These are the same steps you will go through in your activity in order. So this is a good reference tool for you to go back. So the first thing is just reading the question. So we're going to try to find the lightest weight, okay, so light, heavy, or excuse me, not heavy, wide flange, a W12 steel section available to support the live load of 79 pounds per square foot, a dead load of 30 pounds per square foot, and the length of the beam is 18 feet. So it goes from 0 feet to 18 feet. And some things that it's going to say to assume is that its Fy is 50,000 pounds per inches squared. And then the tributary width, like we talked about in activity 1, is 10 feet. Meaning if it's an interior beam, it's 10 feet to the next beam. So it has to support 5 feet this way and 5 feet this way. All right, so first step is write down everything that you're given, right? It's a word problem. Let's break it down. Let's grab that important information. So what's my live load, dead load, my span, how long is my beam, oh, very important, I didn't mention in there that it's supporting a plaster ceiling, what your Fy is and what your tributary width is. And then our end goal is find the lightest wide flange, a W12. Very important, I'll always tell you what wide flange section to start in. Is it a W12, W14, W16, and so on. I'll always give you that. All right, so our next step is to then calculate the load on our beam. So we learned in activity 1 that we have to take our dead load and live load and add them up and then do our uniform load. So the first thing I have to do is convert my live load that they gave me that's in pounds per square foot into the uniform live load. So this is how we did our uniform beam load. So you always have to multiply it by your tributary width, okay, which is 10 feet, and that gives us 790 pounds per linear foot. So every foot on this beam, there's a 790 pounds of live load acting on it. Every foot, that's a lot. In addition to that, we have a uniform dead load that is 30 pounds per square foot multiplied by our tributary width, and we have 300 pounds per linear foot. So in addition to our live load, every foot on this beam needs to be able to hold 300 pounds of dead load. Okay, so then we're going to add that all up. Our live load plus our dead load gives us our total uniform load. So across this entire beam, every foot here has to be able to hold 1,090 pounds per linear foot. So this is a uniform load. Very important to note. You will see a uniform load showing arrows going all the way across, saying, hey, it's the same load pushing on this beam going all the way across. Okay? All right, so then we have to calculate our reaction forces. I'm not making you do these by hand. It's something I did skip this year because it takes a long time. When you go into civil engineering or architecture, you will do this all by hand. They won't give you this cheat sheet in the beginning. You'll have to calculate it all by hand. If you're interested in learning more about that, let me know. I have a whole nother PowerPoint activity we could run through together. So what we're going to use is our cheat sheet. So you could either use table 323 or on your formula sheet. So I wanted to give you both. Formula sheet will help you on the end of course assessment so you know where it is. It's the same thing. But then this kind of gives you a little bit more information, this table. All right, so the first thing that we want to calculate is our reaction forces. Our reaction forces is R, okay? So here's our little diagram of our beam. We have a uniform load. The L is how long it is. W is the uniform load, and R are the reaction forces pushing up on it. So we want to find R. The equation for R for this type of beam is WL over 2. So W is your uniform load. L is your length, how long your beam is, and then over 2. So we're just going to plug in our numbers. 1090 pounds per linear foot times 18 feet, that's how long my beam is, divided by 2, and my reaction force is 9810 pounds. Make sure your units, very important to write that down. So that's step 1, reaction forces. Step 2 now is to calculate that max shear force. Shear force is V. Okay, so remember that maximum shear force, that's going to be at our connection points where our beam connects to a column. So what's the maximum force that will be acting on there? So what you will do is calculate V by using this equation here. So again, W is your uniform load, L is your length divided by 2, and then X is the